to Mathematics Lecture series. In this lecture, we discuss inverse Laplace transform given by S property. Lecture number 15 in the Laplace transform. Before the start of lecture, I request you kindly subscribe the channel and like the video as you find more videos. Given by S property, the statement of that property Laplace inverse if Laplace inverse f of s is equal to f of t. Suppose that if it holds, then Laplace inverse f of s, this f of s, if we divide with s, another parameter, then that will be equal to 0 to t integral f of u du. Here you can also write t dt because u is a dummy variable. Now by Laplace transform of integral property, you know that Laplace of 0 to t f of u du is equal to f of s over s. We have already done in the previous lectures. So kindly you watch the video of that property from the playlist. Now taking inverse Laplace transform on both sides. In this equation, you take inverse transform, Laplace inverse, Laplace inverse. So Laplace inverse f of s over s. Here Laplace will become identity. You will have 0 to t f of u du. This is a simple proof of that property. Solve the example Laplace inverse 1 over s square s plus 2 by the discussed deviant by s property. So first we consider 1 over s plus 2. So Laplace inverse of 1 over s plus 2 e power minus 2t. We compare that property, this is f of t. Now what is Laplace inverse 1 over s times s plus 2? We just from s square just 1 s. We can also write Laplace inverse this one is also we can write Laplace inverse 1 over s plus 2 by s. Now by using this property, that one is equal to 0 to t f of u du. Here f of t is e power minus t2, then transform it into f of u, so e power minus tu du. Now taking integration of that one e power minus tu integration e power minus tu and derivative of minus tu, which becomes minus t and t0. So minus 1 by 2 we write outside and apply the upper limit, which becomes e power minus 2t and minus lower limit e power 20 e power 0. So minus 1 by 2 e power minus 2 e power 0 is equal to minus 1. So if we this minus multiply, then we will have 1 minus e power minus 2t upon 2. That is the Laplace inverse of 1 over s plus 2. Now we consider Laplace inverse 1 over s square s plus 2. Then again we will use this property 1 by 2. Here we just have the Laplace of 1 over s plus 2 is that 1 minus e power minus 2t 2. So this t replace with u and use this property 0 to t 1 minus e power minus 2u du. 1 by 2, here integration of 1 is u and integration of e power minus t u is e power minus tu upon minus 2. Here t 0, apply the upper limit, then you will have u plus e power upper limit t e power minus 2t upon 2, lower limit 0 e power 0 upon 2, 1 by 2 t e power minus 2t upon 2. Here e power 0 is 1 minus 1 by 2. By taking LCM, you will have 2t minus 1 e power minus 2t and 2 multiply with this LCM, you will have the 4. So this is our last answer, e power minus 2t plus 2t minus 1 upon 4. So discuss the example number 2, Laplace inverse 1 over s ln s square plus a square y s square plus b. Now first consider this ln s square plus a s square plus b. Find the Laplace inverse of that one. You know that this is f of s, of course this is f of s ln f s square plus a square s square. So by ln property, logarithm property, we can write denominator with minus ln s square plus a square minus ln s square plus b square. By the logarithmic property, we can write it that way. Now differentiate both sides. So by here f of s, derivative of this f prime s, here ln s square plus a square, so derivative of that 1 over s square plus a square, and s square derivative we write in numerator 2s. Here minus ln s square plus b square, so differentiate 1 over s square plus b square, here s square derivative 2s. Now taking both sides Laplace inverse. Laplace inverse f prime of s, Laplace inverse 2s over s square plus a square minus Laplace inverse to be separately gives Laplace inverse to each one. So here we use that property, Laplace inverse f of s f of t is equal to Laplace inverse nth derivative, that 1 minus 1 power n t power n f of t. So here is the first derivative, minus 1 power 1 t power 1 Laplace inverse of f of s. So that becomes that one by using this property. Now 2, here we write 2 outside the inverse, Laplace inverse over s square plus, here 2 we can write it outside, Laplace inverse s over s square plus b square. So here if we write that one, the Laplace inverse s over s square plus b plus a square, which becomes cosine at. Because of that minus, that will cosine at minus cosine at. And Laplace inverse s over s square plus b square, that one is becomes cosine bt. And that t, we both side divide with t, so this t will vanish. Both side we divide with minus 1 t, so we will have last one is that cosine bt minus cosine at over t after simplification. Now use here the property Laplace inverse f of s over s integral 0 to t f of u du. Laplace inverse f of s, we have considered that one is equal to f of s ln, so we f of s replace with that one and 1 over s. Then by using this property to 0 to t, that is the capital F of t, so that will transform to into u cosine bu cosine au over u du. So that is the last answer of that example, Laplace of 1 over s ln s square plus a square s square plus b square. In this lecture we have completed division by s property with 2 examples. Therefore, for any suggestion, any confusion, you write in comments, and kindly I request you subscribe the channel and like the video. Thank you.